A variable is a storage location in memory that you assign a name and a type of data to be stored. You can later change or use the data throughout your program. There are 8 fundamental distinct types of data you can store in C++. A Boolean, which has the size of 1 byte, a character, an integer, which is 2 or 4 bytes, a float, which is 4 bytes, a double, which is 8 bytes, or a string, which is 12 to 16 bytes or 24 to 32 bytes, depending on the architecture. To begin, we declare it using a data type, followed by the name of our variable, allocating a memory address for it. While this is valid, it's considered good practice to also assign it a value upon creation, or in other terms, place a value into that memory address or location. If you don't, then the value will be set to whatever happened to be in the memory location assigned to it at that moment, or a null value, either way causing issues. Bools can be true or false. Floats are decimal numbers. Doubles are more precise or larger decimal numbers. Characters need to be enclosed with single quotation marks. The reason being, strings are enclosed with double quotation marks, and they automatically end with a null character, meaning this is considered 2 characters. When naming variables, it's good practice to give them a short but descriptive name, so later in your code it'll be easier to identify its use. You shouldn't have 1-character variable names, variables with too many acronyms stuffed in, or incredibly vague names. The rules for variable names in C++ are that names can contain letters, digits, and underscores. Names must begin with a letter or an underscore. Names are case sensitive. Names cannot contain white space or special characters like the exclamation point, hash, percent, etc. And you also can't call them reserved words like int or switch. To use variables, you don't need to re-specify their type, but you cannot ever set the variable to a different type of data. You can change the data contained in variables using a multitude of operators, or setting its value to a variable. You can also define a constant if you don't ever want a variable to be changed. Here's a simple example of a variable being utilized. We start off giving tax a value of 25, and then we set total's value to 12 plus tax, which we previously said was 25, and then we output tax to the console. And here's some examples with the other 5 data types. You can also use modifiers to allow for larger minimum and maximum values, or better use of the computer's memory. There are also more advanced types available for variables: compound data types, user-defined data types, and derived data types. Compound data types consist of arrays, sequential collections of elements of the same type, pointers, variables that store memory addresses, and references, aliases for variable. As for user-defined data types, there are structures, which group together variables under a single name, available to all methods in your program by default, classes, which are similar but also restrict access to variables outside of the class itself and are not available by default, and enumeration, a named set of constants. Finally, derived data types are auto, where the compiler deduces what type it is, using, which simply lets you use a custom keyword for a type, and modifiers, which you saw part of earlier. As for signed ints, they span negative to positive values, as previously shown, whereas unsigned values are strictly positive, but still contain the same amount of values. That's it. Thank you for watching. Remember to Control S, and I'll see you in the next one.